So this is the latest addition to my shop. It really was about time to get a new drill press. After some quick research, I found the Scheppach DP18 Vario, which seemed to match my requirements quite well. With a bit of discount, its price tag is about 220 euro. So it fits pretty much in the middle of the budget for a home shop machine, I think. Its main feature is the Vario drive, which lets you change the speed on the fly. It works mechanically, so you actually gain torque when lowering the speed. Let's see how that works. Now that is quite nicely designed, I think. Although it does not come across on the video very well, the current speed is shown correctly on the LED display. It goes from about 440 to 2080 RPM. The rest of the machine is pretty much standard. With 38.5 kg, it is quite rugged. You also have a relatively silent 550 watt induction motor. Solid base and table. If need be, the table can be tilted and of course be moved up and down and to the sides as well. There is of course a lamp and a laser. These are nice to have, but not really that important for me either way. The overall build quality is decent, even though there are some sharp edges here and there. But that is to be expected in this price segment. I also came across some quite negative reviews for this machine, which mentioned bad runout. So I was prepared to investigate it. To follow up on the runout, I got myself a cheap dial test indicator with base for about 40 euro. For my test setup, I harvested a 12mm steel shaft from an old printer. These printer shafts are usually quite straight and should be good enough for my purposes here anyway. I marked it at a distance of about 10 cm, which is round about where your drills might typically be at. Now if you take a look at the moving dial, you can see that it is quite horrible. There are about 400 micron of play on this assembly. I have played with this before, so I already have a culprit in mind, but let's investigate. I removed the chuck with the wedge that was delivered with the machine. One decent whack and it comes right out. Here. No. Oh, there we go. This is a no-name chuck with a no-name B16 to MK2 arbor. How bad is a fit? Let's glue it up and check. I put the chuck on now. And remove it again. I've placed an old cloth below this to catch the adapter. And I hope I'm not doing this completely wrong, but I will get it out there. Just stick this in here, and it doesn't slide up. Put in the wedge, give it a good whack. There we go. And here you can see marked up part. And as far as I see, there's mostly contact here at the edge and at the bottom, not the whole surface. And the surface gets marred here, which I find which I find quite unusual, because this should be some sort of hardened steel, but it really isn't quite. With this old file, I can clearly file this away, which is not something that should happen with a hardened tool. I don't even know if I will keep this as a spare, or if I just throw it away. To improve upon this situation, I got myself a Röhm arbor, which even just at first glance is of much better quality. A new one. I almost don't want to mess up the new one, but let's see this. Doesn't catch, just removes the black coating. So this is hardened indeed. Yes, this is hardened. Before I mount the new arbor, let's use the opportunity to check the actual spindle. Off camera, I've removed the motor cover so that I can turn the spindle without touching anything else. There are just maybe 1 or 2 micron runout in the spindle itself. Very good, I think. I've now cleaned the chuck inside with isopropyl alcohol, and let's reassemble this. This looks good enough. Let's see where we are at with the new arbor. I think this is quite a worthwhile improvement. 4 times better runout just by using a proper arbor, which is around €12 delivered. I hope there was something useful for you here. Until next time, bye.